Okay guys, in this video, just want to talk about a few things and then we're going to go back to some surface area and volume. So when we have a plane that intersects a sphere, planes can intersect spheres in one single point, okay? That would be a tangential plane. So a plane can be tangent to a sphere if it intersects at only one point. All right, so this is an example of that. Notice when a plane intersects a sphere, okay, the resulting shape is going to be a circle. So if you think about if you have a ball, like a baseball, and you take a piece of paper and you put it over that ball, and then if you were to pick up the piece of paper, if the paper was on, cutting the ball in half, then the hole in the piece of paper would look like a circle. So when a plane intersects a sphere, the result is a circle. Finally, here, that line, this line over there, that's called a great circle. A great circle. So that's actually how we measure. That's how we measure lines in spherical geometry. So in Euclidean or Cartesian plane two-dimensional geometry, we have a line is between 2 points, but actually between 2 points on a circle, there's only one great circle, and that's said to be when a plane intersects those 2 points. So that's just a little bit about properties of circles. Now let's move on to different problems here. I want to find the volume and surface area of all of these objects. Okay, so I want to find volume first. Volume equals 4/3 pi r cubed. Okay, so that equals 4/3 pi times r cubed is 125. All right, so volume is going to equal 4 times 125 is 500 over 3 pi units cubed. Okay. All right, now surface area is going to equal 4 pi r squared. Okay, so we just plug in r, 4 pi times 25. That's going to equal 100 pi units squared. Okay. Now moving on to this problem, it's a little bit different. It looks like a hemisphere. Okay, a hemisphere. So our volume is going to be, all we have to do is cut our volume in half, but our surface area is going to be not just half of the surface area of a sphere, so we have to take that into account. So let's start with volume because I think it's a little bit easier in this case. So volume here is going to equal 4/3 pi r cubed, pi times r cubed, and then we're going to take half of that because this is a semicircle, so times a half. All right, so the volume is going to equal, it looks like, let's see here, this is going to be 1/2 times 4/3, okay, that's 4/6. 4/6 is 2/3, so 2/3 times, it's going to be 27 pi. All right, so volume equals, that's going to be, this is 1 and 9, so 18 pi units cubed. Okay, so that's the volume of the semicircle. Now for the surface area, we need to find the surface area of half. Okay, well if the surface area is 4 pi r squared, then half of the surface area is going to equal 2 pi r squared. But then we need to add in this top part. Okay, we need to add in that top part, which will be the area of a circle, so plus pi r squared. Okay, so the surface area is going to equal 2. So 2 pi r squared plus pi r squared then is just 3 pi r squared. Okay, so that equals 3 times pi times 3 squared. So this is 9. 9 times 3 is 27. So we get 27 pi units squared. Okay. Moving on then, we have another problem here. This looks a little bit tricky. Okay, we're given the volume, but we don't know the radius, and we're asked to find the surface area. Okay, so how are we going to work this out? Okay, so we know that, let me move over here. Okay, we know that volume is 4/3, so 4/3 pi r cubed equals 100. Okay, so we have to multiply this by 3/4, so that's going to be 75. 75, okay, equals pi r cubed. So 75 over pi equals r cubed. So r equals the cube root of 75 over pi. Okay. Now that doesn't look pretty, but that's perfectly fine. We don't need things to look pretty. So we're going to take this and we're going to find the surface area. So the surface area, let's see here. Surface area is going to equal 4 pi r squared. Okay. So that's going to equal 4 pi times this big ugly number, cube root of 75 over pi squared. Okay. So if you forget how to do some algebraic manipulations, basically what you can do is you can square these numbers. Okay. So we can do, this is going to be 4 times the cube root of 75 squared divided by pi squared, okay, times, it looks like pi, times pi. All right. So you can put that in your calculator. You're going to get a fairly, this looks pretty nasty here, but when you put it in your calculator, you get a lot more manageable number. But for now, we can leave our answer like this, and that'll be sufficient for the purposes of this video. So hopefully, throughout this video, you guys learned a little bit more about some properties of spheres. You learned, you solidified your understanding of volume and surface area through these problems. Thanks for watching.